Okay, for this problem, we're looking for the derivative of 6x squared plus 3xy plus 2y squared plus 17y minus 6, and we forgot that's going to equal 3. All we need to do is find the derivative of this. So we're going to do the derivative by doing implicit differentiation, which is basically just a chain rule with a different variable. So first, 6x squared, we're going to take that derivative. That's just power rule, constant multiple rule as well. The 6 stays there and multiplies the derivative of x squared, which is 2x, and 6 times 2 gives us 12x. That one's easy. And then we have 3xy. That's a product, 3 times x times y. Now that 3 is a constant, we can do one of two things. We can keep that constant out in front and do the derivative of xy in parentheses, or the way that I'm going to do it, I'm going to treat 3x as like my f of x, and then I'll treat y as my g of x, so that way I can just do the product rule in that fashion. So my first part of the derivative, I'll take 3x, just leave that alone, and multiply by the derivative of y, which is dy over dx, plus the second function, y, multiplied by the derivative of 3x, which is 3. There's the product rule without having to worry about pulling that 3 out. Then we're going to do the derivative of 2y squared. So again, we got a constant multiple there. We've got the power rule. 2 times 2 is going to give us 4y, but then because that's a y, we have to do the chain rule, implicit differentiation, and multiply that by dy dx. Plus the derivative of 17y, well, that 17 is a constant, so it's going to stay there, and multiply the derivative of y, which is dy dx. And all of the, and then we're going to do the derivative of 6. The derivative of 6 is 0, and so we don't have to worry about that. That's gone, and then that's going to equal the derivative of 3. Don't forget to go equals 0, the derivative of 3. So technically we've taken the derivative of everything. Now it's simply just getting the dy dx by itself. So everything that's a dy dx I will keep on the left side. Everything that's not, I'm going to move over to the other side. So I've got 3x dy dx. That will stay. I've got 4y dy dx, that will stay, and I've got 17 dy dx. That's everything that has a dy dx. Everything that doesn't, I will add or subtract over to the other side, so I'll subtract a 12x. I will subtract, I'll write it as 3y. From here, it's just 2 more quick steps. We can factor out a dy dx out of the left side, and so we'll have dy dx. Left over, we have a 3x plus a 4y plus a 17, and that's going to equal negative 12x minus 3y. And then finally, if I want to solve for dy dx, I can simply divide both sides by the parentheses, and I'll have my derivative dy dx equals negative 12x minus 3y. And all of that is over 3x plus 4y plus 17. There's our derivative. We can use that now if we wanted to find the equation of a tangent line, find the equation of a normal line, do anything we need to do with derivatives. We've got the derivative. From there, we can do whatever we need to do.